right? Maybe.
Mute this.
Is there sound right now?
Thank you. I apologize, the video was muted, so so again, in today's lecture, we're going to focus on the location of facilities within an area. So the question of where to place a new facility if you want to serve more customers, or where to place the next warehouse, so you have better access for your customers. So that's the type of question that we want to answer with this lecture. And then in this slide, I was discussing that how location fits in the operations management philosophy. And you can see in the managing value chain, the location area is, or the location piece is highlighted. So using operations to compete, operations as a competitive weapon, you have operation strategy, project management, basically the area in which you're focusing on planning. Given the constraints, given the budget allocation, based on what you want to achieve, you design these strategy. And then once you have that strategy, then you want to manage some the processes that involve process strategy, process analysis, performance and quality, constraint management, the layout, and also improving the performance in terms of lean systems. And then managing the value chain, we go into the supply chain strategy, the location of the facilities, new facilities, how to manage the inventory, how to forecast, and how to use that data to make better decisions. Resource planning and scheduling. So as an example, for this topic, I have here a BMW decision that was made in the 80s, in which they were evaluating they were trying to bring some of the business to the United States, and they were deciding where to place the new factory. So this was in the late 80s. Fluctuating exchange rates and rising costs convinced BMW that it was time to consider operating a new production facility outside the European borders. So blank page, meaning that they wanted to evaluate everything from scratch. Approach was used to compile a list of 250 potential worldwide sites. The analysis pared the list down to 10 options, and a location in the United States was preferred due to its proximity to a large market segment for these vehicles. Okay, so they know they had a market to explore and also to have a lot of customers here in the United States. So they end up deciding to put the next facility in the United States. But the question was, okay, now we know that we have decided in the country to locate the new facility. But in the United States, you can place this factory in many states, different locations. So how to make that decision? So they spent 3.5 years considering the labor climate. So these are things that, again, going back into the decision process, you might think that this is more like a technical type of decision, but you also have to take into account these societal aspects, such as labor climate, port and road access. So how far are you from your customers, and how far are you in terms of being able to move these vehicles to the areas where your customers are? Your geographical requirements and constraints, airport access, and its relations with the government. So can they get some type of tax exemptions, and do they have access to labor? That's another thing that is very important. So when you see, for example, Tesla making these decisions of moving to Austin, they're also looking at all these aspects. And one of the most important ones is the labor. Can they get access to, in their case, engineers? So they're located in this area. They know they have multiple universities that can supply that need. So that's also an important factor for them. So in this case, the plant was located in Spartanburg, South Carolina, and now employs about 4,700 workers who produce more than 500 vehicles a day. So they decided to go in that direction. So in terms of facility location, how is this problem or this decision associated with facility location? Facility location is the process of determining geographic sites for a firm's operation. So these are location decisions, where to place the next facility. And these decisions affect processes throughout the organization. So they involve marketing. For example, they must access how the location will appeal to the customer and the possibility of opening new markets. Human resources must be done to the firm's hiring and training needs. So this goes back to my comment on having access to new engineers or people training technology. So when you see these companies moving to these new cities, that's one of the most important aspects. That's why California, in addition to having good weather, they have very good universities, and they have a lot of companies located there. Now we're seeing the same trend here in Austin, Central Texas, with us here, UT, all these universities around the area. Accounting and finance must evaluate costing. So again, going back into the trade-off, can we get some tax exemptions and so on? And operation needs to be able to meet current customer demand and provide the right amount of customer contact. So all these areas are part of this decision. Managers must weigh many factors when assessing the desirability of a particular location. The factors must be sensitive to location, and the factor must have a high impact on the company's ability to meet its goal. If those are not met, those conditions are not met, then we don't necessarily have to look at those aspects or factors. We want to consider only those factors that are going to have a high impact on the ability of the company to meet the goals. So what are the dominant factors in manufacturing? As I mentioned already, a labor climate that is good. This might be the most important factor in these labor-intensive industries. So do you have people around these areas? You have people that you can hire for these positions. I believe when Amazon moved into San Marcos, we went through a phase in which Amazon was competing with HEB in terms of hiring people to manage their warehouse. So at some point, it was not enough people to run both of them. So they started competing for the same labor. So do you have enough people that can move to the area? Is the area a good area for people to move from other cities or states? Quality of life, good schools, recreational facilities, cultural events, and attractive lifestyle. So that's another important factor, especially for these big companies that attract a lot of people. Proximity to suppliers and resources, important when inbound transportation costs are high. So if you are dealing with a car manufacturing, do you have access to suppliers that are located close by, so your cost can be reduced? Proximity to the parent company facilities, and utilities, taxes, and real estate costs. So again, very important. So these are the dominant factors in manufacturing. So in terms of proximity to customers, how conveniently customers can carry out business with the firm. So if you are going to be, for example, supplying to these car dealerships, are you located close by? How easy is it for you to transport and send these cars to the dealerships? Now we're seeing a different trend in which some of these companies are moving into ordering it online and you deliver the car straight to the customer. So if that's the business model that you want to follow, is this the right location for that? Transportation costs and proximity to markets. What are the competitors? So are you going to be, as I mentioned already, competing between HEB and Amazon for the same human resources? So estimating the sales potential and impact of competition. Critical mass is a situation whereby several competing firms cluster in one location attract more customers than the total number of who will shop at the same store at scattered locations. So this is very important, for example, for locating healthcare facilities. Like also a few years ago, you will see a lot of these 24-hour, it's not hospitals, but urgent care facilities popping out everywhere. And some of them were able to stay afloat, some of them need to close because they were competing for the same people. So this is associated with this critical mass. situation. And then site-specific factors, including residential density, traffic flow, and site visibility. So in lately, the use of GIS is becoming very popular for this type of problems. We can gather a lot of information now from different sources. And there's a lot of good software that will allow you to pop up some of the data that is available in different sources. And you can use that information for making decisions. For example, ArcGIS is one of the software packages that is pretty popular that you can use to make this type of assessment. I think at Texas State, we have access to ArcGIS. If you need it, for example, for research, you can access the software. We have licenses. And it populates a lot of data, like it could be demographic data, economic data. If you need to know where the hospitals are located, you can get that data and put it in a map. Anything that you might think about, you might be able to pull. And if you're not able to get it from the software, you can also import some of the information that will be needed. Yes, thank you. So QGIS is free, and it's also a great GIS program. So that's what I'm saying. There's these packages, these software packages that are available that are very helpful to make these type of decisions. So, so you can use these databases to manipulate, analyze, and present information relevant for location decisions. So it can be used to store database, display maps, create models that can take information from existing databases, apply analytical functions, and write results derived from the analysis. So together, these three functionalities of data storage, map displays, and modeling are a critical part of these intelligent GIS used in varying applications. So again, we use this approach a few years ago, and I was using ArcGIS with one of my graduate students to study the problem of locating trauma health facilities in the state of Texas. So we're working with the Department of Safety and Health here in the state. They gave us some data about the trauma injuries that are happening around the state, and they gave us information about the hospital locations. So if you don't know the difference, trauma facility, not every hospital is a trauma facility. Trauma facility take care of major injuries. Like if you have a car accident and you're injured, you go to a trauma facility. If there's a gunshot, you go to a trauma facility. So it has to be a big health situation typically that is managed, and there are different levels. So not every hospital is a trauma facility, and not every trauma facility is equipped to handle every injury. So if you are, for example, in pretty bad shape, you might need to go to a trauma facility level 1. And we only have 18 in the state. So Texas is pretty big. Most of these trauma level 1 facilities are located in the center of these cities like Austin, Houston, Dallas. So if you're located far from those and you have a very bad injury, or if injury is pretty bad, then if you're not, you don't have access to that type of hospital, you might die. And that's the problem that we were trying to study. So how much of the population in Texas might die if they have an injury of that level and they don't have access. And we also study the problem from the perspective of if you need to open a new trauma facility, where it should be located. So the problem involves all these things that we've been discussing so far. So it's not just a decision of saying, let's open a new facility in Amarillo, because Amarillo might not have all the factors. For example, as we mentioned already here, to attract doctors. So that's one of the main issues we have. Like we can say, okay, we need to put a hospital in this rural location, but then you are not able to hire doctors that want to move into that area. So how do you solve that problem? So how do you make those cities more attractive to bring these type of resources and being able to serve the community? So some of the things that are being proposed, as you know, some of them will have helicopters. So they might go in the helicopter and bring the patient to the location of the trauma facility, but sometimes that's not enough. I mean, if you're located pretty far away, you might not be able to get to the hospital on time. So that's an example of considering all these factors in terms of making those decisions. And even if you consider all of that, you might not be able to find a solution. So we propose some expansions for them. They're under consideration right now, but those are the type of issues that we end up having. And as I mentioned, so just to close on that application, they are waiting for this new level of connectivity, 5G connections. So at some point, they might rely on having this virtual, I would say, procedures, like in which a doctor in Austin might be able to handle some of the surgery from their location using some type of robot in the hospital. Also, training people, maybe not at specialist level, but having the specialist in Austin guiding the person in the location, that's another strategy that is under consideration. So, you know, some of you are not aware of these type of differences, but sometimes as you move forward in your career, when you try to get jobs in other places, those are the things that you might need to consider as well. I'm allocated close to a trauma facility. What if I have an accident? Will I be able to survive? Yeah, so moving forward, UPS and site selection in the fast food industry. So this is another example. Until recently, fast food chains use consultants to analyze these demographic data for strategic planning and making franchise locations. But now with the availability of these easy to use low-cost GIS systems, these large fast food or small fast food chains are doing this on their own. So they don't have to hire these consultants anymore. They, as I mentioned, with these software packages, you can make the analysis. So this program can estimate the total dollars up for grabs in a market. And you will see that in example by analyzing local age and income data from the US Census Bureau, and as well as sales data from stores in the area. The programs can also tell the optimal number of locations of stores in a market and how much in sales stores can expect. Analysis can be run for any US market and can rank markets in order of viability. So for example, here, Starbucks, if you're familiar with the Kyle market, we didn't have any Starbucks. We only had a Starbucks in Target at some point and one in close to the HEB. And now there are like two more or three more. Yeah, so suddenly we got like three more Starbucks, all of them in a 10-mile radius. So how are they making these decisions? So the store locations, here we have the Starbucks store addresses within 20 miles of Hamilton, Ontario, where it came from the Starbucks website and imported into MapPoint. So this is an exercise to get all this data, we put it into the map. These store locations are denoted on maps by yellow dots. So I'm going to show that in a minute. And demographics that come with the MapPoint were overlaid on the map. On the first map, in this Oakville has more stores locations than Hamilton, even though it has lower population density, suggesting that store location is not being driven by the population density alone. So this is what I'm referring to. So population density, the darker the color, the higher is the population density. So as you can see here, we have this area with higher density than this area. And even though the population density is different, this area has more Starbucks locations than these and this. So the assessment So we can say that the decisions are not being made in terms of population density. That's not the main consideration. On the second point here, the second map shows that by demographics, by average per capita household income. Note that in this case, the store locations are based in more affluent areas. So it's not only population density, but also in order to make these decisions, they are looking at the economic, not value, but the economic amount or demographics per capita household. And you can see, like, if you look at this average household income here, close to the 100,000, these areas will have a darker color. These areas will have a darker color. And most of the Starbucks locations are in those areas where the average household is pretty high. So this tells you their strategy, right? They're looking at these areas, fluent areas, and then they're trying to locate their stores in those areas so they can give them access for people that can spend for the product. So that's one example, on-site expansion, new location, or relocation. So these are three possibilities, right, that you have. You don't necessarily have to open a new location. You can just expand the location that you already have, or you can close the location that you have already and build a new location in somewhere else. So on-site expansion, new location, or relocation. So the managers must first decide whether to expand on site, build another facility, or to relocate to another site. The benefits of on-site expansion is to keep people together. So you don't have to hire new people or fire people. You basically add more to your current location, reducing construction time and costs, and avoiding splitting up the operations. However, if firms expand the facility, at some point, these economies of scale setting. So if it's too expensive, at some point, you're going to have to increase the cost of your product, and that might put you in a different situation. So a new plan allows it to hire more employees, install newer, more productive machinery and better technology. And also, if your business has changed, let's say in the last 25 years, customers are better customers or better suppliers are located in other places, you can make a new decision and that can save you some money. So remember that these facility locations decisions are for long periods of time, right? So you're not a new facility for 5 years. So typically you build a new facility, you're gonna stay there for 20, 25 years. And a lot of things can change in that period of time. So building a new facility might put you in a different position in terms of getting the advantages of the changes that have happened in the last 25 years. So most firms that choose to relocate are small, let's say 10 or less employees. More than 80% of all relocations are made within 20 miles of companies' original locations, which enables the firms to retain their customers. So here's tying our discussion back to healthcare. So this is Tyler Emergency Medical Services. The location of 2 existing EMS emergency facilities in Tyler, Texas are shown in the following map. So these are the population densities. Again, darker the color, the higher the population density. And we have these 2 EMS locations here, one located in the north side and one located close to the center. So we have also identified these areas as areas of rapid growth. So these numbers right here denote the census codes. So we have 20.04, 20.06. So these right here are areas of rapid growth. So northeast or southeast, I'm sorry, areas. The population density for each of these cities tracks is shown. So as I mentioned, darker the color, the higher the population density. And these southeast areas are the ones that are growing really fast. So the residents of this tract have complained, tract 18.03. So that will be this right here. They have complained. That it takes too long for the EMS vehicles to reach them. So these are ambulance services. So if you have a problem, you need an ambulance, how fast they can get to your home and they can take you to the hospital. So they are being complaining about that. So again, here's the locations of the EMS facilities and the illustration of where the highest or the areas of active growth are located. So general guideline for locating EMS facilities in urban areas is that EMS vehicles should be able to answer 95% of its call within 10 minutes in tracts that have population density of 1,000 people per square mile. Okay, so that's the minimum requirement. So census tract 7 on the west side of the city with a population density of 967 people per square mile should be included in the study as well, because it's pretty close to 1,000. Thus, the census tract that are as dark or darker than census 7 or tract 7 should be within a 10-minute drive of an EMS facility. So the question is, knowing these requirements, where should the EMS locate these 3 facilities so that it meets its coverage goals for Tyler? So here's census 7, the one that we were mentioning. So if we were to plot, again, these are things that we can easily find out with these ArcGIS or other software packages. You can, based on the normal traffic conditions, how far or the location of that will meet this requirement, being able to be within 10 minutes of the location, which is these EMS and the EMS2. So the areas that are covered by EMS2 are in red or are circled by this red line, and the areas that can be covered in less than 10 minutes are covered by this blue line. Those are the 10-minute response zones. So if you look at the map, there are some areas that are still uncovered. And that's why this area right here was complaining, because there's no way for them to get to the EMS location within 10 minutes. So the question is, how can we rearrange this configuration so we can get access within that 10-minute mark for all the customers? So under the assumption that these or 1 or 2, let's say at least one of them can be moved or relocated, we can add a new facility. This is the new EMS2, new EMS3. This one is the same that we had before. And by adding this new location, this is an example of a possible solution. You can locate the new EMS facility here, close to 18.03, and then a new EMS facility here, and then keep this one here, and then you will be able to reach the locations without problem. Now, in terms of locating a single facility, when the facility is part of a firm's larger network of facilities, we assume that there is no interdependence. The process of selecting a new facility location involves a series of steps. So it's typically the problem, right? You have a network of facilities already in place, and then you're looking for expanding by adding a new facility. So you go through that process one facility at a time, typically. So the process of selecting the new facility location involves these steps: identify the important information factors that we already discussed and categorize them as dominant or secondary. Consider alternative regions, then narrow the choices to alternative communities, and finally to specific sites. So you can make this problem as big as you want, but it will take you longer to get to the final decision. So if you filter out this location, let's say you end up with 10 possible sites, then decision-making process can be expedited. Collect all the data needed on all the alternatives, analyze the data collected, beginning with the quantitative factors, bring the quantitative factors into the evaluation. The site with the highest weighted score should be the best. So here's a health watch preference matrix. So if you are locating a new medical facility, in this case, Health Watch is to be located in this area, Pennsylvania. The following table shows the location factors weights and the scores from 1 to 5, 1 being poor, 5 being excellent for one potential site. So we have here the location factor. We give them a weight, right? So this is given by the decision maker. And the location factors are listed here. These are the important factors for their situation. Total patient miles per month, facility utilization, average time per emergency trip, express away accessibility, land and construction costs, and employee preference. So these are the weights. And then we can score, let's say for a particular location, we can fill out the scores. So for this particular location, we have these scores, and then the weighted score is the multiplication of the weight times the score, and you get the total here. So if you have multiple locations and you are completing this weighted matrix for each one of them, at the end, you should be able to decide which one is the best based on these weighted scores. Another application, management is considering 3 potential locations for a new cookie factory. They have assigned scores shown below to the relevant factors on a 0 to 10 basis, where 10 is the best. And using the preference matrix, relocation will be preferred. So here's an example of a single location. Here we have 3 different locations. Obviously, these are made up just to illustrate the problem solution. So we have the location factors, we have the weights, and then we have the 3 alternatives, right? And based on the factors, we're going to provide a score from 0 to 10. And we are going to compute the weighted factors for each one of them. And then we end up selecting the one with the highest weight or weighted WS. So in this case is 6.8. Pretty simple, right? It's more an evaluation. You have the factors, you have a weight, and then you're scoring and then selecting the one with the highest weight. Application 2, this is revisiting the distance measures. So what is the distance between this coordinate and this coordinate? So we had 2 ways of measuring the distance, and there are methods to make these decisions that consider these different type of distances. So for example, we can consider the Euclidean distance, which is looking at this, the theorem, DAB equals the square root of the difference in the x different of in y to the square. And then that gives you the distance. And then the rectilinear distances, that is basically looking at, instead of the diagonal, is looking at the summation in terms of y and x. So based on the type of distance or method of measuring distance, there are different methods to solve this problem. So applying the low distance method, this is a mathematical model used to evaluate locations based on proximity factors. A load may be shipments from suppliers, shipments between plants or customers, or to customers, or it may be customers or employees traveling to or from the facility. So what we're trying to do is to minimize its load distance, right? So the more you travel, longer the distance, the harder for you to get the customer there, or the more you have to spend to transport these items. So we want to minimize that load distance so that the large loads go short distances. To calculate this LD score for any potential location, we use the actual distance between any 2 points using a GIS system and simply multiply the loads flowing to and from the facility by the distance traveled. So summations, this is a summation for all locations of the multiplication of that load times the distance. So for example, here we have an application. Management is investigating which location will be the best to position. The best to position is new plant relative to two suppliers. One of them located in Cleveland and Toledo, and three market areas represented by Cincinnati, Dayton, and Lima. Management has limited the search for this plant to those 5 locations. Following information has been collected, and which is the best, assuming rectilinear distances. So we have this information, we have the XY coordinates for each location, and we have the number of trips per year. So these are the trips per year that are going to happen between these locations and the new facility. So looking at each one of these locations, we can estimate the LD multiplication, load times distance. So for example, for Cincinnati, that first distance is going to be 0 because you're assuming that you're going to place the facility in Cincinnati. So no distance needs to be traveled. And then for the rest of them, you have a distance. The next one, so the total will be 810. For the second one, same situation. Dayton is going to be the location. So you compute the distance, the weighted distance for the other 4 based on Dayton. 920. You get Cleveland. Total is 660. Toledo, we get 690, and then Lima we have 590. So based on this, what will be the best location? Lima, right? So it's the one with the smallest, since you're trying to minimize, this is the one with the smallest weight. Yes. I guess there's has to be a typo there. I assume it's this one right here. We can measure that. Yeah, but if you do 20 times 5, this is 100. 40 times 8, this is much 32. 320. 320 plus 200, 520 plus 15 times 8, 120. Yeah, I don't think it's 690, right? It's less than that. Yeah, so that's the distance for this one. I apologize for this. I don't remember the number, but this is incorrect. The distance for 30 times 0 should be a different distance right there. Yeah. Thank you. Okay, another strategy is called the center of gravity. A good starting point to evaluate locations in target area using the load distance model. So we are going to determine the X and Y coordinates of different locations, either in the form of the longitude and latitude of the locations, or by creating an XY grid. The center of gravity X coordinate denoted by X star is found by multiplying each point X coordinate, either the longitude of the location or the X coordinate on a grid, by its load Li, assuming these products the summation of Lj times Xj, Xi times Li, and dividing by the sum of the loads, the summation of all Li's. And then the same thing for Y star. So these are the two equations. So we are multiplying the summation of the load times the distance from just looking at the X or the longitude. We do the same thing for the latitude, and we will obtain a weighted distance that will tell us what will be the position for the new facility. And this is called the center of gravity. Problems with this approach is that you might not have an area to locate the facility once you solve the problem. Let's say the coordinates are on top of a hospital. So you might not be able to use that location to place the facility, right? So these are some of the disadvantages of these methods. Unless you are pretty sure that that area will provide you with a piece of land that you can use for your, or a place that you can rent for the facility, then you might face those problems. So finding the center of gravity, the new health wedge facility is targeted to serve 7 census tracts in Erie, Pennsylvania. Customers will travel to the 7 census tract centers to the new facility when they need healthcare. So what is the target area center of gravity for this new medical facility? We'll use map point in this solution, and coordinates will be presented in the form of latitude and longitude rather than X and Y grid to calculate the center of gravity. And the target area is displayed on the map of Erie using map point. Punch pin is placed in the approximate geographical center of the census tract, and the location sensor is then turned on and used to obtain the coordinates. So this is information that we have for each census tract. We have the population, latitude, longitude, the multiplication of the population times the latitude, and the multiplication of the population times the longitude, and we have the totals. The total for the population, which is going to be the weight, right? The summation of the loads. In this case is the population. And then we have the multiplication of the population times the distance, in this case, the latitude. So X star is the longitude and Y star is the latitude for the center of gravity. So in this case, applying these two equations, we get the location in terms of latitude and longitude for this new facility. Again, we pretty straightforward, but then when you try to implement this into the problem, you have to make sure that you have to find an area in that location or close to that location that will be available for opening the facility. So here's the center of gravity in this case. So this is where the new location will be placed. And you see we are basing this on these centroids, right, for these areas. So that's the other, I would say, limitation. So you're assuming that the centroid is going to be used as the reference point for the population. So if you have a big group of people, let's say living in this corner, not here, but in this corner, these results might not be efficient in terms of managing the needs of the community. Application form, a firm wishes to find a central location for its services. Business forecasts indicate travel from the central location to New York City on 20 occasions per year. Similarly, there will be 15 trips to Boston, 30 trips to New Orleans, and the XY coordinates are given here. What is the center of gravity for the demand points? Again, we multiply the number of trips times the distance, and we divide it by the summation of the weights, and we get the location in terms of X and Y. So that's in terms of this weighted or center of gravity approach. Any questions? This is very straightforward. Any questions? Okay, so now I'm going to discuss a different strategy. This is called the break-even analysis. And this can help a manager compare location alternatives on the basis of quantitative factors that can be expressed in terms of total cost. So this is more like an economic type of chart that we are going to develop, in which we're going to, you took economics, right? You have all these break-even points that you use to make decisions. So this is the same idea. We're going to determine the variable costs and fixed costs for each side, plot the total cost lines, the sum of variables and fixed costs for all the sites on a single graph, and then we're going to identify the approximate range for which each location has the lowest cost. and then solve algebraically for the break-even points over the relevant range. So in this case, we have an operation manager that had narrowed the search for a new facility location to 4 communities. The annual fixed cost is considered and the variable cost as well, labor, materials, transportation, and overhead. And we have this information. The costs are for 20,000 units. So we have the fixed cost for each community, the variable cost per unit, and the total cost, which is the summation of the fixed cost times the variable cost per unit, which in this case is 20,000. So this is the total fixed and variable cost. So step 1, we are going to plot the cost curves for all the communities on a single graph, and then identify on the graph the approximate range over which each community provides the lowest cost. So here we have community A in this red line. We have community B in this blue line, community C in this green line, and then finally this pink line right here is community D. So as you can see here, right away, you will see that D, the option D, is not, I mean, based on this, you will say this is very expensive. And that's also shown here in the graph. So there will be no area in which that option is going to be less expensive. It is expensive or more expensive up to this point, but even after that point, it's still pretty expensive. So in this analysis, then the idea is to look at this, I will call it a frontier, right? This line that is going to be the lowest line across the plot. And then you identify algebraically these points in which these two lines are going to intersect, and this point in which these two lines are intersecting. And then you are going to split the area under the curve. And those are the areas in which each one of these options are going to be better. This is in terms of changing quantities, right? So for example, in the x-axis, you have the quantities in terms of thousands of units. So if you are between 0 and 6,000 units, this community A is the best location for you. If you are between 6,000 and 14,000 units, then community B will be the best option for you, or less expensive option. And then if you are above 14,000 units until more than 22,000 units, then the best option will be option C. Okay, so that's the idea. You're just not getting a final solution for every possible situation. In this case, you have a comparison plot that can help you make decisions in terms of what will be better according to the amount of business that you are planning to have. Any questions? So using the break-even analysis, we can calculate the break-even quantities over the relevant ranges. If the expected demand is 15,000 units per year, what would be the best location? If we go back to the plot, 15,000 is in this area, so that will be that option C. And this is how these break-even points are computed in case you need the numbers. So you know what you're doing here, right? You're using the line function, making it equal to the other line function that are, so for example, this line and this line, these are the equations for those two lines. And you're solving for the intersection. Same thing here. Obligation 5, by chance, the Atlantic City Community Sheds has to close temporarily for general repairs. They're considering 4 temporary office locations. So here's the information. We have the moving costs for each one of the property address and the monthly rent. Use the graph to determine for what length of lease each location will be favored. This problem, lease length, is analogous to volume. So it follows the same process. You're going to plot the lines for each one of the options. And then you're going to look at the months and the total cost, and based on the intersections, you can decide which one will be better. So it looks like the intersection is happening at this point. So changing decisions will happen after 6 months. But before 6 months, this Baltic Avenue option is the less expensive. After that, looks like this Sun Charge Place is the less expensive. The boardwalk, just like in the other example, is just never a good option. The use of GIS tool often simplify the search for a solution when facilities are interacting. So in this case, let's think about a network, right? A network of facilities. So GIS tools will simplify this search. We can map the data for existing customers and facilities in the GIS. Visually split the entire operating area into the number of parts or sub-regions that equal the number of facilities to be located. Assign a facility location for each region based on the visual density of customer concentration or other factors. Or alternatively, determine the center of gravity for each part of sub-region, determining step 2 as the starting location point for the facility in that sub-region. So this is going into higher level, I would say, larger area. And now we have multiple facilities that needs to be studied. Search for alternative sites around the center of gravity to pick a feasible location that meets the firm's managerial criteria, such as proximity to major metropolitan areas or highways. And compute the total load distance scores and perform capacity checks before finalizing the location for each region. So here's an example. We have Witherspoon Automotive delivers full truckloads of parts to its customers, return with a shipment of used automotive parts for disassembly and remanufacturing. So it's a two-way process. You go deliver any new parts, and then you bring the ones that needs to be remanufactured. The company presently operates out of 2 locations in the South, Spartanburg, South Carolina, and Orlando, Florida. Each of these locations has a remanufacturing facility along with an attached warehouse that serves as a distribution center. The Spartanburg facility covers a total of 362 customers in Georgia, North Carolina, South Carolina, and parts of Alabama, Tennessee, and Virginia. The Orlando facility covers a total of 66 customers, mostly in Florida, and a small portion of Georgia and Alabama. The Spartacus DC and Orlando DC ship at 17,219 units and 4,629 full truckloads respectively to their customer last year. So you can see here that the volume that this facility is, Spartanburg is managing is 3 times bigger than the one in Orlando, at least 3 times bigger. So here's the map. We have the Orlando service area and the Spartanburg service area in the map. You can see that that area in orange is much bigger than this area in Orlando. And we have the location of the Orlando factory in blue, that blue square right here. And the Spartanburg factories are here in this blue rectangle. And then the red dots are the location of the customers. So this company has decided to close the Spartanburg facility because of its age and obsolescence. And split the Spartanburg region into 2 new regions, each which is own manufacturing and distribution center. 5 important location factors that will be impacting the decisions are the following: quality of life. So the facilities must be located in a major metropolitan area. Distribution costs are a major determinant of profit, and so the total load distance score should be minimized. Economics of scale, so the size of the 2 new facilities should not exceed a maximum of 9,500 truckloads output per year. The customer truckloads allocated between the two facilities should be fairly balanced given the previous year demand data. So we don't want one of the facilities taking most of the load. So they want to have like as close as possible and even split. And marketing has indicated that they are going to develop the Northern Alabama market. So they want to go develop this area right here, which is kind of empty now. So marketing wants to expand to that area. Thus, the new distribution network should be able to accommodate up to an additional 1,000 full truckload shipments per year from the Alabama market. So here's the location and number of full truckload shipments delivered last year in these areas. The darker the color, again, the higher is the volume. So you see a lot of business here, these areas, South Carolina as well. So here we are now focusing, the analysis is focusing on this orange area from the previous map. The Orlando area is not considered. And here we have to partition the customers into two regions, each with the demand of less than 9,500 truckloads. So here we have the customers. So you can see here's a high density of customers located in this area. Also here. So there's like big clusters located in certain areas of the map. So based on this visual visualization of the customer locations, they're saying that it seems reasonable for the management to locate one of the two facilities near Atlanta. And then the second center or the center of the second region is around this area right here. Based on the center of gravity, seems like this area right here is the location. So it's close to Charlotte. See, we're looking at this area right here. Let's say the second center should be somewhere here. And they look at the center of gravity, and it looks like somewhere here is that location. So that's where this is, close to Charlotte. So the Concord site was selected based on the highway access and travel. So this problem basically decided to put one of the locations, split that old factory into two areas. One would be located here. The other one was decided to be here somewhere, and they used the center of gravity to decide on the location, and also including those factors that were listed. Access was one of the main things, so they wanted to put it close to the highway. The transportation method, so is another strategy that it could be used to make these decisions. Is a quantitative approach that can help solve multiple facility location problems. So if you took operation research, most likely you are familiar with the transportation problem or transportation model. That's what we are going to be showing here today. So you basically pick the location and you solve the transportation problem and find the cost. So the transportation method does not solve all facets of the multiple facility location problem. Uses linear programming to minimize the cost of shipment from two or more plants or sources of supply to two or more warehouses or destinations. So the first step is in solving the transportation problem is to format in the standard matrix. Sometimes this is called a tableau. The basic step is setting up an initial tableau as follows. We create a row for each plant, existing or new, being considered, and a column for each warehouse. So plants, right? These are the current plants. This is at the top, we have a column for each warehouse and a column add a column for plant capacities and a row for warehouse demands, and insert their specific numerical values. Each cell not in the requirements row or capacity column represent a shipment route from a plant to a warehouse. Insert the unit cost in the upper right-hand corner of each one of these cells. So this is what I'm referring to. So you have the plants, you have the warehouses. So each one of these boxes is representing a node or an arc in this transportation network. So going from Phoenix to San Antonio warehouse, and you have the associated distance between these two. Or in this case, is the unit cost in the upper right-hand corner. So how much is going to cost you to move one unit from Phoenix to San Antonio? $5. From Phoenix to Hot Springs, $6. From Phoenix to Six Falls, San Diego, $5.40. And then we have a capacity of production for each plant. So 400 for Phoenix, 500 for Atlanta. And then we also have the requirements in terms of demand for each one of the warehouses, 200, 400, and 300. And the question now is, now that you have this information, how much or how many of these 400 are going to be shipped to each one of these locations? How many of these 500 are going to be shipped to each one of these locations? You want to cover the demand with your capacity, but at the same time, you want to minimize the cost. So if you solve this, for example, using the simplex method or a Excel solver, you can find a solution for this problem. You set up the constraints in terms of supply and demand that we just covered. The objective function is to minimize the summation of the shipments. You meet the demand. By meeting the demand of 900, capacity is the same. So this is a balance problem. If you remember, there's a difference on balance and balance problems. So what is balance? 900 supply, 900 demand. You can solve the problem pretty easy. But if it's on balance, you have to do an additional step. But that's outside our discussion for this class. So this is the final solution is basically telling you how many of these units are going to be shipped. We can get some information here. There's a dummy that we typically add, and this is what I was referring to. When the problem is on balance, you need a dummy. But in this case, that's not a problem. So you can see that Phoenix is shipping to 2 of the facility. Atlanta is also shipping to 2 of the facilities. And something that you can see from here is that either one of them, actually Phoenix is shipping more to this location in San Diego. But if you expand the capacity of Phoenix, you can cover this node. You can cover this node right here without the need of Atlanta. So those are the type of things that you can study and get some insight in terms of, okay, so I might not need so much capacity in this location. Maybe if I add another node in a different location, I can cover my my destinations with a smaller cost. So Atlanta should ship 400 units to Hot Spring at a cost of 4.60 units. So this is the map. You see Phoenix is covering San Antonio, and then Atlanta is covering these Hot Springs, and also both of them are covering that location. South Dakota, I'm sorry. Node application, see how much time we have. Okay, so let's do one more and we can complete the discussion on our next lecture. So application 6 is the Firebrand makes picante sauce in San Antonio and New York City. Distribution centers are located in Atlanta, Omaha, and Seattle. And the capacity demands and shipment costs per case are shown below. So this is the same framework that we saw in the previous problem. So we have the demand and we have the capacity. So you see here, we have more capacity than demand. So that means that we have an unbalanced problem. However, since we have enough capacity to cover the demand, that shouldn't be a problem, meaning that we're gonna have additional capacity left at the end when we solve the problem. So problem will be that you have a higher demand than supply, then you might need to compromise in terms of which customer you want to leave without the full order. So shipping costs to distribution centers are here. So we can solve this problem by setting up the initial tableau. As we did for the other problem, we have the demand, we have the capacities, and then we have the cost. So the problem will be, again, to set up this in terms of minimizing the total cost of shipping when you allocate these warehouses to destinations. So yeah, this is not solved. So I'll stop here. Let's continue our discussion on our next lecture. Will be on Monday. And then on Wednesday, after Monday, we are going to have our review because the third exam is on the last day of the semester, which is May the 1st, I think. Right? May the 2nd. Let's see, let me just confirm. I don't want you to get confused. May 2nd, correct. So Monday, May the 2nd will be the final of the third exam. As you remember, the final is optional. So if you do well in the first 3 exams, you are happy with your grade, you don't have to take the final. Yes.
The final is optional, but if you take the final, you don't drop one of the other tests, right? You take it all together.
Yeah, that's correct. So if you take the final, the weights of the previous exams are adjusted. So they have a smaller weight and the final will have a bigger weight in the final grade. Typically for students that are 2 or 3 points below the next grade, it would be a good idea to take the final. But if you have an 80, you should not take the final with the hopes of getting to an 8, for example, because it's not going to take you that far. Okay.
And Professor, is that online as well?
The final will be online, yes. So the exams, the third exam and the final will be online, yes. Any other question? Good. So I'll talk to you on Monday. Again, I have office hours today, this afternoon at 3:30. If you need to talk to me, you can, or if you can't make it to those office hours and you need to talk to me, just send me an email and we can schedule a different time. Have a good afternoon.